Welcome to Vegas Programmers. Yay! Thank you everybody for coming out here. Obviously without you, I'd just be talking up here by myself. So I appreciate everybody coming out, supporting the local tech community. I've been running PHP Vegas, now called Vegas Programmers, for over 10 years now. Once a month, even through COVID, which COVID sucked. We had to do it online. But once Tech Alley popped up a little over 2 years ago, it was a perfect opportunity to get back together and share, and it's been awesome ever since. So we've got a cool format today, a little different. Instead of just like two just talks or one big talk, we kind of got it broken out a little bit. So we've got one talk that's going to be done by Rich, that's going to be talking about testing with containers. And then we've also got Delaney with DataStar, a no-code development solution, right, that you're kind of working on, and just want some feedback from developers on it, right? Which I'm interested to see, what you got cooking. So, cool. So with that said, a couple of announcements. One, Tech Alley has treated us very well, but my schedule is going to change. I'm doing Little League for my son and all this coaching, and Saturdays are going to be booked for me. So that leaves me in a situation where either for the next 4 to 6 months, I've got to have somebody else run it, which I don't want to put that on somebody. So with that said, next month is going to be our last month at Tech Alley. So then the following months from there on out, we'll be at a location that I'll share next month. The good news is the new location is going to have desks, and you will all be able to work more collaboratively there. We've had workshops in the past where we've taught how to use things like Kubernetes or Docker, and it's been nice to be able to bust your laptop out and kind of work and have that kind of environment, because we're programmers, right, or aspiring programmers. So it just gives a little bit more opportunity to help the people getting into it and actually showing them what they're, in front of the computer, like, hey, here's how you do it or whatever. So again, thanks to Tech Alley for hosting us. Thanks to Ryan for always recording these and stuff like that. So there's that. I do have a JetBrains license to give away as well. So they're a sponsor of ours. They create things like PHP Storm, PyCharm. There's a bunch of IDEs they have. Like IntelliJ costs $800 a year, free. If you want the license, just grab my card up here at the front. I have my email on there, email me, and I have 4 or 5 of them. So feel free to reach out and I can get you hooked up. We are looking for, obviously, a venue sponsor. I have one in mind, but I'm trying to find, just weigh the options out there. If you know of a venue, you work at a place here locally that could host us, reach out to me. And then the last thing is just speakers. Rich here, without him, I'd be up here speaking for the 11,000th time, and I kind of get sick of it. I'm sure you guys get sick of me too, right? I mean, nobody wants to hear my lisp all day long. So with Rich here and other people who have spoken in the past, huge shout out to them. I appreciate them stepping up and contributing back to the community, right? We can't just consume, but so I tell my son, don't watch YouTube videos all day long. I'd rather you make a YouTube video than watch YouTube videos, right? So give back when you can. So thank you, Rich. I appreciate giving back. And without further ado, we'll kick things off.
Okay. Hi, my name is Richard Strokman. I'm a software testing consultant. And so I've been doing a lot of testing with Docker over the past few years. And I'm wondering how many people have experience with it or use it on a day-to-day basis? Okay, about almost more than half, maybe. This is might just be a review for you. Feel free to shout things out at me if you have tips or anything that you want to give to people, and other people, if you have questions, just shout them out. So one of the great things about Docker is that if you're using it in a software development environment, it works on my machine, then you talk to the tester. They have a different configuration. Some of that problem gets abstracted away from us. So the agenda here is, what are containers? Why would you use Docker? How to install and use it? And then I'll show working with code a little bit, some API testing, and how to run some automation tests. I don't know how much we're going to be able to cover in the 30 minutes, but we'll sort of play it by ear. So what are containers? Containers are basically an isolated computing environment. They're running on top of a VM or on a laptop, like in my case, I just am running on a laptop here. And you could have many containers running within a single virtual machine on the same Linux kernel. So they run on Linux kernels, basically split with their own namespaces in order to keep the security between the different containers. They have good security. It's maybe not perfect. That's a detailed conversation, but it's probably good enough for even defense government work. It has configurable networks and volumes, so you don't have to go out and have a switch or have a hard disk. That's all virtualized. But these containers are ephemeral, so they're started to run a specific task and then they exit. And of course, they're highly configurable. There's probably millions of different Docker containers out there. You can get them off of. Help people. Can you hear? Oh, that's better. Okay, thank you. So there's obviously infinite possibilities that you can configure your Docker container. So you don't have to, have the software. You don't. On a lot of the cases, you don't have to worry about setting it up because there's already been a container created on the Docker Hub, and they're multi-layered, which gives you the advantage of you can reuse things and not have to continually rebuild an entire container. You can just take all the stuff that's already been built and changes just get built back in onto the next layer. And they're very lightweight and you can limit the CPU and the memory, and that's all configurable within it. Now that's generally containers. Now Docker is a business that uses this open source software, and so there's a daemon called Dockerd that runs as the server, and Docker Desktop is the client application that you use to manage the containers. Oh, can we hear? Okay. On Linux, it runs natively, while on Windows, there's a little bit of gray area, depending on whether you're running Windows subsystem for Linux or a hypervisor. On Mac, it's using a VM, so I'm using Mac. There's a VM, but this is all runs under the hood. You don't even really necessarily have to know about this, but just know that Docker uses a Linux kernel. And the desktop application, you can do, I'll show you in a little bit, you can do some basic container management and debugging through that. And this is, so they went to a paid model a couple of years ago. It's free for smaller organizations, but the larger your organization is, then you have to buy a license for it. Docker Compose then is also built into Docker now. It used to be a separate project, but now it's part of Docker. It's used to orchestrate your containers locally. So you don't have to run a Kubernetes cluster on your laptop just to use containers. You can use Docker Compose, which is a lot simpler. And then obviously, if you can debug your containers and then send them to the cloud, which is lots of cloud services that manage containers like EKS or ECS, or Google Cloud Run is a fairly simple one. That a lot of them, they run on Kubernetes for the most part, and some of them take the Kubernetes part of it out of it, and they manage it themselves. So why should you use Docker specifically for development? Well, the configuration is part of the container, so you don't have a bunch of you don't have to install something and then run a bunch of scripts to make it work. You just have to start the container, and there you have everything. It works pretty well with your source code management and your IDE. Probably a lot of VS Code users here. There's built-in applications for using Docker with the IDE. Interpreted languages, so you could even mount your code base and you can make changes on the fly and see the code changes reflected immediately. You don't have to work that way, but that's one potential way to work with a container if you're using something like Python. And they're fast, they're easier to manage than a VM. You have to have a VM to run it on, but then you can have one VM and have many different services running on the same VM. Now, conceptually, for the first time, it can take a little while to understand exactly how things are working, but you do a build that creates an image from a Docker file, and the images they're static, and they're created through the build process. And they can be tagged with versions, or often with the, you use something like whatever your image name service is, latest, that'll be your latest version. And they're marked with SHA numbers, so if you need to access a previous version, you can reference them that way. Containers themselves are the runtime of the Docker images, and any changes made locally should be rebuilt into a new image. I say that specifically for a tester. So if you have a software developer and they make code changes, then you would build a new image to be tested. And then containers can be stopped, they can be restarted, paused, and so an important point of these is they're not meant to be like long-running processes. Or they could be long-running processes, but they're not meant to be changed or to hold state. They're stateless, so they're meant only to be run for a short period of time, and use volumes or databases as your state. So Docker resources, like I said, they have networks. Every container has this bridge network by a default network, and you can create other networks. So not everything has to be on the same network. Oh, went out on me. Not everything has to be on the same network. They can communicate with each. You can one container can communicate with another container on the same network using it like an alias name. And volumes are created and they persist without the containers running. So you create the volume on the host itself, and then whatever containers are running can then access the volume. And then, so there's another way. So those volumes are just sort of like free-floating volumes, but you have bind mounts that actually bind to your operating system or your hard disk, so they can work directly on the local disk. So that's one way you could develop locally, like I said, with an interpreted language. And all can be specified in a Docker Compose file or at the runtime. So I'm going to start showing a little bit of the runtime and then some of the Docker Compose. Now with Docker Compose, it's basically, like I said, local container orchestration. It specifies resources for a project. Enables the defining of the network, the volume, the containers, all your dependencies, external services, and some environment variables. You're able to rebuild quickly when changes are made, and it's now packaged with Docker. So you just have to type Docker and then Compose. It's part of the Docker program. Are there any questions on this part?
I have some questions, but I'll save it for when you open up some examples.
Okay. Okay, let's start with where's my browser? Up to my browser. Oh, this is why. Okay, so I was just going to explain what the basis of this project is. There's this real Python. They have like tutorial projects, and this is one that is real simple. It's an API, and it has multiple steps in it that goes from using in-memory data, and then it moves on to having a database. But that's just sort of the background of what the base application is here. So I was just using that because anybody can go and rebuild this themselves, and the source code is on GitHub. Now, if you're going to Dockerize an application, you need to create a Docker file. So for the base here, there's a Python container on Docker Hub, and this tag is this 396 Alpine. Alpine is a common Linux that's used in Docker because it's very lightweight. You could use Ubuntu or Debian or other distributions. Alpine's pretty common in Docker because it's more minimal. So the Docker file is the instructions for how we're going to build the container, or build the image, I mean. Workdir is just where do we start? So these are line by line. It'll run through each one of these lines. So it'll copy the requirements.txt. So if you aren't familiar with Python, you can use pip to basically freeze all your dependencies, and you put those into a requirements.txt file. So all the dependencies are here, and we're copying these dependencies into our /app directory on the container. And then run pip and install all the dependencies. That'd be one step. And then we're going to copy all of our source code into the app. And this build database is going to build our first data, it's the base data for the initial conditions for the database. Then we're going to expose this port 8000. So ports can be a little bit tricky. Your application will have a port on the container, and then you'll need to direct it to which port do you want to have exposed out to the, on the VM or whatever on the host that you're using, so you can access it that way. And then there's entry point. I made a change here because it made a complaint about. So there's two. If you look here, it says run Python 3 build database.py. So when you do an execution, you can just type it out like you would on the command line. So this is how you do it, Python 3. But for entry points, it wants this JSON format, which means it does one command, or one part of the command, and then the next part of the command. I'm not going to get into too many details there unless somebody wants to correct me. So what an entry point is, this is how the container starts. And this can be overridden when you actually start the container, but by default, it executes the entry point. And that's the program that runs. And when that program finishes, the container shuts down and it's finished. So this is an application, so it'll keep running. Okay. I need to do a build. Where's the build? Sorry, I'm trying to figure out how to do this with one hand here. No, not that. Oh, there we go. Okay. Okay, so here's a build command, docker build, and then -t tag, so that's basically just giving it a name. And then, like I said, this colon, you can give it whatever version you want to, but if you give it latest, then it'll keep updating to the latest. And then this dot means I want to build by default, it wants to build from this Docker file that's in the current directory here. So now we have a build, and I'm going to go to okay. So this is the UI that Docker provides. So we see that just now, this is pretty nice because you can actually do a lot of things here that you used to have to do on the command line. One thing is that you can just take a look at this and see all sorts of information about what happened in the build. So this is a good place for debugging build, and it shows you your Docker file, all the logs for the build. So this is the source of the Docker file, and these are each of the steps, and it shows you what happens in each of the steps here. And then it says they're cached, which is important because it means that anything that's cached can be reused. Okay, so now that we have a build, okay. Okay, we should have an image. Oh, well, so this was a cached image. So the image is still here. This is something I built earlier today, but it would have built a new one here. Let me just go back here. I'm going to delete this. So you can delete here. You can delete your images. And I'm going to rerun this. Is that right? Oh, I guess it did. The cache is still there, that's why. But say I want to run this, so I can just run and give it these settings. Now here, in order to get this to work, I have to give it because this is an API. So I need to give it a host port, so I'm going to give it the host port of 8000. I can give it a container name. I'm going to say demo1. Okay, now it's running. I can actually show you what this does now. Get back to my... This is not the right one. Hang on, I'm just trying to find the browser I had here. There we go. Ah, there we go. Okay, so this is what it is. This is built and has a Swagger UI. So the nice thing about Swagger here is that it gives you all the API functions here, and you can run your tests directly within this. So if you just go. This thing is now running at 127.0.0.1, port 8000, and it's just a database that says hello people, and it's got these different characters with notes about themselves here. Now, so you can get a note that says try it out, or get people, and it shows me, okay, here's the people list. Now, what if I want to make, well, let me get into Docker Compose for a second here. So I actually, I created a second, like a database Docker file. It doesn't need this. This is just sort of for demo purposes. There's to show what happens when there's multiple containers. So it's basically the same container. This does build database. And then typically when you want a container to keep running, even though it doesn't really have a purpose, you can use tail -f/dev/null. This is common usage for things. This one has a sleep of 3. because I want to show how the dependencies work. So Docker Compose is a way to run this with all your setup information set here, so you can rerun it the same way every time, not have to go through all the command line stuff each time. As much trouble as I am seeing this. So this is the dev app. This is YAML. And the first one is the main application. And it depends on like I said here, the dev database, which is down here. And then I just added, maybe it's dependent on Perl. So it's going to go out and grab this Perl image. And the build context, so each time you tell it to build, it will create the build based on the Docker file. And then I have volumes. So there's a shared data on this volume. So I went and I created this data volume. I have volumes here. Data. So I have a data volume. And this is shared between everything. Now, so Docker Compose up will build everything based on that Docker Compose file that's in your current directory. And if you tell it /build, then it will actually do the rebuild each time. And then the /d means it's detached. Let's do it without that. It'll be running in the foreground here. You see there's sleep here. So we're saying that was a database container. So the main container has to wait for the database container to come up. And then we can actually run then the main application will run after the database comes up. So my container list is here. My database is not running. But anyways, okay. So if you want to see what's going on inside your container, you can look here, and this is called the exec. I don't know why it's doing this. Oh, it's not letting me do this all of a sudden. I click on the wrong thing. Okay.
Can you turn the UI?
Try to run it with -D just to bring everything up, but turn off the one that you manually ran with 8,000.
Oh, okay.
Because I think that's conflicting with the port right now, and it's shutting everything down. Yeah.
Oh, okay.
I would turn that off and then do. Now try to run that.
Okay. So if you want to bring everything down that's in your Docker Compose, you can do Docker Compose down. That will remove the containers. And then, all right, we'll do it with the dash. We'll do it in the background here. Are they running? Oh, so, okay, I just can't tell with the colors here. There we go. Now it's letting me execute. Okay, so I'm actually, this is the same as doing a, what's the name of the container? Oh, it's RP Flask API. Anyways, you do this exec-it, then the container name, and then bash, and that's what you're getting here. You're getting a shell. So this is all the code in the container that was copied in when it did the build. So it's all right here. And if I go to data, I have a file because this is a persistent file. So your volume persists, and this can be used amongst different containers. They can all use the same one. Now, okay. Oh, okay, yeah, so my database is running. I'm getting thrown off because the colors are all completely different. Data. So you can see now we have another file, and if I go back in here, it shows up there. So that's how the shared volumes work between the different containers. Okay. Any questions at that point?
Have you dealt with any like advanced flags for the Docker volumes? Have you had to use like rsync or other? There have been situations for me where I've had like a ton of code in a volume that gets mounted, and it's super slow on Mac because I think of the virtualization. I've had to mess around with flags before. I'm just curious if you ran into that or.
No, not necessarily, but I know you can mount them in different ways, like read only, or there's different ways that you can mount the volumes.
Yeah.
And obviously, like I said, volumes can either be on the operating system itself, or they can be these other volumes that are just the sort of the floating volumes here. Okay, I had a lot of other things I want to talk about, but that's like 30 minutes, so I don't know if I.
Yeah, we can go for like at 3:30, I would say.
Okay.
Yeah. Does anybody have questions so far about Docker and its usage? Or there a particular like use case or things like that?
So I think you said in the intro that you use this for like application testing. Can you maybe talk about how you do that?
Yeah. Well, I guess let me talk about what happens with like code changes and things like that. So now we see if I was a manual tester, I'd say, okay, it does this hello people. There's the tooth fairy, or I could use this Swagger UI to do. This is a Postman would be probably something you'd use more often than this, but this is kind of a nice little built-in feature of this app that it has the Swagger here. But most APIs now, they do have this. So you can go through and test things locally. But I guess I want to talk about what happens when there's code changes. So over here in the home HTML, you see it says hello people. So let's change this. Okay, we have a code change now. And let's say that's been, well, if you're the same person, this is pretty trivial, but if there's somebody else that made the code change, then they would, they do a commit, it'd be on Git, you'd pull the Git commit, and then you could use Docker Compose here to rebuild your image if you've got it set up this way, where you do those manual steps I showed earlier. And so it's running through more steps than it did before because there was a code change. So it's going to the point in the Docker file, which is basically this. It sees the copy app. It sees the app changed. How is this cached? Export an image. But the new code's getting copied in, and now I can test it and say, okay, oh, well, I got something different here. so I can see, oh, this is a good way to verify bugs have been fixed or things like that. Now, some automation testing, which I have set up here somewhere. Where's my automation testing? Oh, okay. Yeah, so I've got some PyTests here in API test. Okay, so one of the first tests here is that test get people, or test hello world. Okay, so I was looking for this hello people in that text, and if I run this test, this is going to stop at the first failure, right? So it says insertion error, hello people, this failed, and it gives me, okay, there's a problem here. So go back and fix I can fix the test, I guess. Now I have to rebuild.
Do you have to rebuild, or do you have the volume mounted?
No, I don't have the volume mounted. Yeah, that's the other way you can do it. You can if you're making changes locally, and you do have to watch out that you don't like write recursively onto your volume. So you.
Yeah, I think that's where my slowness came in, was because I was using mounted volume. So any like file that changed, it has to do like this parsing stuff underneath the hood, and if there's a lot of files, that's where things got slow.
Were you using like dev containers? Essentially, like where you're developing from within the Docker?
Correct.
Yeah. On Windows or Mac?
Mac. Yeah.
At work, we use dev containers, and it's amazing because some of us use Mac, some of us use Windows. But I don't know if it's just something in our setup, but the Windows guys are like 10x slower.
Slow, yeah, that's what I hear now. Like
Usually
Linux
it's
is super
with
fast because it's just
the NFS level. If you do it in Linux, it's a no-op, but in Mac, and it's basically depending on if you're using VFS or not, it can make a big difference. So, oh, sorry, NFS, sorry, yeah.
So you mentioned dev containers. I think, is that right? Dev containers?
yeah, like just.
I think those run on Java,
So
I
you don't have to
believe.
rebuild every time.
No, so a dev container is essentially like, I guess in the setup you have here, right? Like you, at build time, you build your container, right? But developing, you probably have to have Python install on your machine to run it. Dev containers, essentially you put your whole development environment
Oh, okay.
into a Docker container. And so like we have guys who are on Mac, we have guys who are on Windows. I don't even have Node.js installed on my machine. I have it installed in the Docker container, and then I do all my development within the Docker container. And it doesn't matter if I install a different version of Node.js on my machine. It's not going to conflict that we're using a legacy version for our app, and then stuff like that just kind of gets I don't know.
The part in the beginning where he was talking about hypervisor versus WSL, I bet there's something there that can help benefit them. Because I bet you they're using hypervisor, maybe switching to WSL, or vice versa may help.
Yeah, if they're on
Or
Windows.
just telling all the Windows developers to learn Linux.
So anyways, I'm just going to run my automated test here and show that, 11 of them passed. So that's something, if you've got an automated test suite, then you fix your bug, come through and run it again. And then if you don't have any questions on that, I guess I can talk about Jenkins for a second.
So at Jenkins, you would run that test, essentially?
Yeah. Do I have Jenkins? I swear I got the wrong stuff here.
Check the second tab.
Second tab there, yeah.
Oh, okay, yeah. He looks green on my machine. I don't know. Yeah, so I have this Jenkins project, and this, I'll show the configuration here. Oh, actually no, the configuration is not really in here. The configuration is actually in my IDE. So this uses pipeline. If you install the Docker plugin on Jenkins, number one, I don't recommend doing this on running Jenkins on Docker itself. Install Jenkins natively on whatever host you're on, and then install the Docker pipeline. And then when it actually runs, it'll run everything on Docker containers. It'll spin up Docker containers to run the pipeline using a Docker agent. Here it's just checking to make sure, okay, Python's installed, and then it's running this build database to set up the initial conditions on the database, starting up the application, and then moving into the test directory and running these PyTests. So what it does is it pulls the code from GitHub. I can run. This might work over my phone. I think it's going to. Shouldn't take very long. It does a declarative checkout, so it checks out, and then does the agent setup, builds the app, runs a test. I think it's just having a little trouble updating here, but you can look at the console output and you can see everything that happens here. It says, of course, up here it says, okay, first thing it did, it obtains the Jenkins file from Git, and I have Jenkins installed here on my host, but obviously you can run this in the cloud, or you can run this through AWS or whatever, through like code build. So it does all this Docker, all the setup here. Okay, all this stuff is cached here. There's been no changes. I didn't commit any code here, so all this stuff is cached. And here's where it starts running the tests. So make sure that you can create a person. It gets a single person here, creates a note, etc. And so I think this is a really ideal way to run automated tests pretty quickly, without having to do a whole lot of environment setup on your Jenkins server. Okay.
Very cool. Any other questions before we wrap up? Awesome. I have one question.
Yeah.
It's more related to Jenkins. I've used it in the past, and lately I've been moving more to like GitHub Actions or GitLab pipelines, ADO. Curious, because the Jenkins file was new to me. I remember writing pipelines in the past where Jenkins was a pain. It seems like Jenkins has come a long way. So do you use this commonly still? Is it pretty, like Jenkins is still pretty alive, or do you see it kind of slowly being phased out?
Yeah, I don't know. You probably survey the audience, but I think it's still used quite a bit in industry.
Seems like larger companies.
Yeah, especially larger companies.
Yeah.
I have one small question. So on Kubernetes, have you used Kubernetes before? And like here you demoed like a single Docker container, right? What if there are multiple Docker containers and management? And how does like Kubernetes come into play amongst all this?
Yeah, I'm not a real Kubernetes person. You can run Kubernetes. It's actually built into this Docker desktop now, so you can, if you want to play with it, you can actually install it here on Docker desktop. But yeah, the point of this is that you use Docker Compose mainly to build your application locally. Obviously, if you have a much bigger application, it may need to be deployed on Kubernetes in order to test it. But I think as a tester, you're looking at trying to break things down in small enough units that you could run it on using Docker Compose, and then the ops people then would probably be more in charge of the Kubernetes setup of it.
That question
Oh, go ahead.
Kubernetes is a container orchestrator. If you're a large company, you might have hundreds or even thousands of different containers that you need to administrate, create all the things he's doing of create the template, create containers, run things in containers. That can get a little tricky, keeping track of all those containers. Kubernetes is an orchestrator. It will help you do that task of keeping track of your containers and figuring out, making sure that you know which containers you have, why you have them, when you have them, so on and so forth.
Does it do auto scale also?
I don't know.
All right, round of applause for Rich. Thank you very much. That was an awesome talk. Thank you, thank you, thank you. As a follow-up to the Kubernetes thing, the co-organizer Cody has done a Kubernetes workshop in the past, and that was probably about 6 months ago. We're due for another one. So later this year, we'll kick it off again. Just stay tuned on meetup.com, and when we update the meetup, the one that says Kubernetes workshop, I'll have him do that one again, because it was really helpful to learn Helm, which is kind of the Docker Compose of Kubernetes. And yeah, it was really good to kind of catch that. Do you still have the microphone clipped to you by chance? Yeah, let me grab that from you. You can clip this one.
Yeah, absolutely.
All right, next we have Datastar. So he's looking for feedback, so I figure here at the end, it looks like you got like 28 minutes. Hopefully that's enough. Yeah.
So I want to know before I start, how many of you are web developers? Can you raise your hands at all? Backend developers? Okay. What languages are we using for the backend? SQL? Or okay.
C#, Python, PHP.
Yeah.
C#.
C#. You go?
Go.
Okay, so we can be friends. Okay. just checking before I get started. So this is actually the first time I've presented about this. This is something I've been working on for the last year and a half. Oh, also before I start, is there anyone that's actually heard of HTMX before? Okay, one person, or two people. Awesome. So if you have, this might be really interesting to you. So this is actually the first time I really talked about it in public. I'm going to be doing a talk next month at JSConf, and then another one's happening in Dublin at BSDConf with another person that's developing it. So yeah, this is about taking old ideas from the web and making it useful for the modern world. So let me get started. I'm Delaney. I'm basically a resident Las Vegas person. I've been here for about 25, 30 years. I tend to have, my entire career has been around reactive content. I was a game developer. I was a 3D artist and then became a programmer, and then went into a bunch of military applications. And the whole time it was about building really interesting content. I worked on The Sims, stuff like that. So everything I've done has been very UI and game dev driven, trying to gamify every project I work on. And a lot of that ends up building web UIs because it's a sandbox environment. It's really easy to get WebGL working anywhere. It's really accessible. It may not have the highest frame rates compared to native apps, but you can get it anywhere. And especially in military applications, that matters more than raw performance for a lot of things. I've been doing this for 25 years. So I was part of the original .com stuff. So I've used every single SPA application framework all the way through and got deep into the weeds on all of them. I also love Nats. If you're a Go developer, you might know what Nats is. It's a distributed platform for doing like really hardcore big things that can handle millions of messages a second. So I like big hard problems, and so I joined the Synadi team about a year and a half ago, working on Nats, which is pretty cool. But I'm the guy who actually goes on site and works with proof of concepts and building demos for Fortune 100s, and I'm constantly making the front ends and the UIs for these things because we can handle millions, even billions of messages a minute, and trying to show that off is really hard in most web development platforms. So it's already a challenge, and trying to put that all inside of a SPA is a challenge. Yes?
Instead of full screen, can you just make it a smaller window so it fits up?
Yeah, no, that's
the projector's kind of screwy right now.
Bottom's cut off.
Let's,
Pull the bottom of it up.
yeah, I just can't see the bottom to pull it. Let's see. Hold on. Let's see. Can I drag it over? I'm sorry, guys.
Or just tell us what it's saying.
Okay. Sorry, because I'm using Linux with a tile window thing. It doesn't want to. It's saying, why would you ever want to do that? Hold on a second. It thinks that I'm crazy for doing that. That does fit. That's the presenter side. That's funny. Let's see. Let's put that one there. We'll go try to move this one over. Wow, this is... I'm sorry, guys. This is a little bit of a... Let's see. Come on. Tiny. Get it. Get it. There. Okay. And we... Okay. Can you guys see now? Yeah. Okay, sorry about that. I should have looked behind me. Apologize. So I found, at least over the last 20 years, that building single-page applications is a major pain. So even with all these frameworks, I was always unhappy doing the stuff. All the things you run into when you build a spa, all the NPM, gigs of content to put like 10 kilobytes on screen seem kind of crazy to me. You always have to do all your client routing, and that doesn't match the server-side routing. Validation, you're doing client-side validation, and then having to redo all that on the server. Security with cores and all that. It's a big hassle that I found, keeping JWTs alive and rotating tokens and stuff. All these kinds of things that I found are really difficult. And the biggest thing that I found that was the biggest pain point, even when I was doing full stack, when I was in charge of the back end and the front end, is this idea of JSON and a quote REST API. It's weird that REST has become to mean the exact opposite of REST. This is Roy Felding. He's the guy who actually invented the term REST. And if you're using JSON with a Swagger API, you're not doing REST. And we can go into the details of that, but it does matter because it's basically we've kind of gone this crazy way that makes it really hard to build things dynamically. So I started doing this in the commercial, saying there's got to be a better way. I felt like this guy is ridiculous, but I actually felt like him at this point because I was like, I've been doing this so long, I should be better at this than this guy, but he is my spirit animal when it comes to Svelte and Solid and all these other frameworks. So I started looking at like, could I do a server-side approach? And this is a few years ago at this point. Like I was worried about latency, obviously. I was worrying about how do you write components in a backend language of choice. Am I literally just going back to what I was doing in 2001? I was really worried about that. So I did start looking at some stuff. I looked at LiveView, which is in the Electro world, Hotwire, DHH worked on that, and Unpoly was another one that I looked at, but none of them really quite fit right. I even started working on a Go implementation of the Livewire directly in Go to do this WebSocket stuff. The problem with WebSockets is you get into a lot of things around sticky sessions and having completely different handshakes. There's a lot of extra issues there that you'll run into. So if there's two people that know about HTMX, that's good. It really is a new way of looking at this stuff. Basically what you do is you take a regular page that you generate in any backend framework, any backend, and you start adding these hxget, hxtarget, all these kinds of little tags on top of them. And then what happens is it talks to the server, you can make these indicators show something's loading, talks to the server, and then updates the content right back to you. And so instead of changing out the entire page, you're only changing out little fragments of the page at a time. So it's basically going back to the real idea of REST. So for example, if you have a bank account or a bank app, you don't know what your next thing you're allowed to do is until you actually take an action. So once you log in, you can see, hey, I have a CD rate. Hey, here's where the checking accounts I have. I'm able to open up a new checking account. All these things you don't know about until the time that you're actually looking at the UI. So you don't have to version. You're not doing an RPC call. You're literally only showing what you're allowed to do at that moment. And so there's a lot less state to take care of. And it's a lot faster to work in. So there's actually a book, even if you're not into HTMX, there's a book called Hypermedia Systems. It's an amazing read. It kind of gets you back to the good parts of the web, and especially part one. After that, it becomes kind of an HTMX specific tutorial, but Hypermedia Systems is really a strong read for anyone that's in this space. However, I started hitting major issues, and this is a few years ago at this point. In fact, Carson, the guy behind HTMX, he wrote a whole thing that literally is that this HTML sucks. So he brought up all the points that I brought up, and he didn't say, I'm going to fix them. He just says, yeah, it sucks. So there you go. But the thing is, there's a thing inside of the HTMX community called Rule 7b, which is basically, if you want a feature, go build it. That's literally what it is. So I actually went and tried to do that. I said, look, because I was trying to make some extensions, and I said, hey, this TypeScript would help a lot here, because what you're doing right now is really complicated and there's a lot of assumptions being made. And so I went off and made a version of it like that. So I moved it to TypeScript Invite. When I say hundreds of issues, it's actually closer to 800 issues, and HTMX is only like 4,000 lines long. So I ran into like 800 issues while trying to go through it. And also he likes just pure JS. So there's an entire Discord channel dedicated to me yelling at people, yelling at clouds as an old angry man, trying to get people to change. But by that time, I'd been way deep in the weeds of how it works, how Alpine works, how all these frameworks work. So I decided, I really do like this approach. I just don't agree with the implementation. So the things I wanted out of it was I wanted every single thing to be a plugin, so you could pick and choose the parts of it that you needed. I wanted to be HTML compliant, and what that means is for a lot of backends, if you're trying to generate HTML, things like HX dash or X dash from Alpine, all these things they're not HTML compliant. So your parsers and stuff may like hiccup because they're like, you're trying to do something that's not actually valid HTML. So I wanted that back. If you're deep into the web world, signals are kind of more well known than they were, but basically it's a fine-grained way to do reactivity that's really fast. I didn't want any VDOM, so gets rid of Vue and Svelte, or Svelte technically doesn't have VDOM, but it's a little more complicated than that. React, all these things do something like VDOM. And I wanted to do server-sent events first. I think that's a technology people aren't using as much as they should, in that it's just a regular HTTP verb, but you can basically chunk down messages on the fly, so you basically get direct access. So instead of doing a request reply, you can just do reply, 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 and you're having your overall round trips. And also wanted all the things that you get out of a standard SPA, so two-way binding, scrolling, animation, transitions, and I just want to completely be able to replace a SPA in any language, but I was special if it's Go. So, and also I really wanted to focus on the tree shaking, because the problem with HTMX and all of these other things is that there's this huge ball of code and you can't pick and choose. So I wanted to be able to only pay for the parts that I needed. And I wanted it easy to add a bunch of plugins. So I figured that long term there would be a marketplace of ideas and you could just pick and choose, kind of like a Unity plugin store where you just pick and choose the things you need and you build the framework you need. So I started thinking about what would that actually look like. Like, let's think that if anyone doesn't know, there's a thing built into the browsers called data attributes. And what that means is anything under the data dash prefix you have access to, and you can add and choose. It's almost like you're having your own little key value store in each element on a page, or each element of like a div or a thing. You can add your own little attributes. So I'm like, okay, that's built for us to play with. Let's see what that would look like. So I started by saying, well, if I want a signal or something that's reactive on the page, I need a place to store that. So okay, I'll do this data store, and I'll turn this thing into a JavaScript object. But instead of just being a JavaScript object, I'm actually going to turn that into a reactive signal. So anytime that thing changes, I can do something with it. Cool. Now let's say I'm going to hook that in so I have two-way binding. So in this case, I'm doing data-model, and then that's going to hook into that signal that I generated up here. Okay. Again, this is me just working out, API-driven development, seeing what I want my future to be. And then if I want to hook that in somewhere on the page, I can do a data-text. And the $ in this case is basically saying this is a reactive signal. Whenever this changes, I want this to get rerun. Okay. So I made my own little DSL here of what I think it would look like. If you've used Svelte, this is very similar to the way the bindings and stuff work in that. And then from here, I still want it to be a standard. So under the hood, it's a signal, but it still is a JavaScript object. In this case, it's a string. I still want to be able to call functions like toUpperCase or whatever on those things. And then, for example, if I'm doing something where I want to do visibility, because turning things on and off reactively is important, I can hook that up. In this case, I made a new thing called data-onClick, and that just hooks into all kinds of different, so anything that's built into the browser, like data-keydown, data-click, data-offline, online, all these things, I want them to be easily accessible, and I want to have access to all of them without having to write extra plugins. And in this case, I'm reusing the show and basically toggling it on and off. Hopefully this is pretty clear, even though it's not technically JavaScript, but it's just a declarative way to do this stuff. And again, you can drive this from any way that you want to create templates in the backend. And in this case, I'm turning that on and off. So in this case, I don't have to worry about, it's going to automatically do all the CSS transitions of fading in, fading out. I don't have to worry about that. And if I want to control that, I can add modifiers and do some special things. But I want it to work well out of the box. If you've ever used Alpine, it looks very similar to this, but it's not using signals. It's not as powerful at like a deeper level, which we can get into later. And the cool thing is, I basically accomplished everything, because this is the first piece of code that I wrote on a napkin saying, hey, here's what I want. And if you include this little CDN script somewhere on your page once, you're done. Like, all this is a working element. So you just write stuff declaratively and move on with your day. So that shows you kind of how you have interactivity on the page, and you might have signals. But what happens if I want to have same thing HTMX has, where you basically are dropping down stuff from the server onto the page? Well, in this case, I did a data dash on click, and I have this $$ push. Now, the $$ is just basically saying this is a sandbox function. There's a bunch of plugins that add their own functions. You don't want to just run eval on the page, because eval is evil. So I'm actually generating, using function constructors and some other magic, sandbox functions that are saying this is what's allowed to be run inside of this expression. So in this case, there's this thing $$ put. It goes, starts a server-sent event, and then it now has a connection that as it sends out events, it's going to update the page. Where is it going to update on the page? Well, every single server-sent event has details about where on the page to update, what do you want to do that. So for example, if you want to replace it, append to it, insert above it, all that kind of stuff is built in, and then the fragment. So in this case, I would just put the ID of output, and the server-sent event would target that ID, and it would just update on the page. So again, all this interactivity with basically just a few changes to some elements on the page. So really it is just, yes?
That put, does that correspond to the HTTP put?
That's exactly what it is. It's actually a HTTP put that is using SSE, so server-sent events. So it's basically sending a text event stream. So it's sending down, you know how when you do a form multi-part encoding and you're pushing parts of a form up? It's kind of like the inverse of that you're basically able to chunk down responses. So instead of waiting for the whole response to get done, you can start sending down chunks of the response. So in this case, you're sending a individual piece each time you want to update something on the page. So yeah, but on the server side, it's just a normal push with, it basically looks like a server-sent event that comes off the post, and you just basically start sending down events. It is a post. It 100% is a post.
It's a put, that's different.
Well, no, okay, in this example, I'm doing a put. Yes, but I'm saying it's a put, it's a post, it's a patch, it's a delete. It's just a normal HTTP thing from the backend.
So that's REST.
Yes, this is REST. Yes. So the point is that the idea of data star is that it should be data-star attributes all the way down. So you just take all the stuff that you normally have to do to write the JS code, put those into signals, make that reactive using attributes, and then you just get back to your application logic, hopefully. And then after that, you profit. So yeah, that's literally what DataStar does. It's taking very simple ideas of turning stuff that, it's not really a no-code approach. It's basically, it's making it a declarative approach so that it works in any backend. One of the key features that's different for people that have ever used HTMX, it's very much a pull-based approach. So every time you update the page and then interact with it, you have to go do a request and then do a response and do a request and a response. So people have made snake games and tic-tac-toe and all that, and you'll see them doing a million requests to the server to keep that going. And in the DataStar approach, you do that request, you get back a response, and you can keep getting back responses. 0 to millions is what I'm using it for. But again, it's still normal HTTP verbs. There's no WebSockets. It's any server that handles flushing, which is basically every modern browser. You don't even have to worry about it nowadays. And you get all the HTTP stuff. It works on any load balancer, all that stuff out of the box. So I knew that I needed to build out some plugins for doing all this kind of stuff. So I wanted all the binds and the text modules and all the things that you would get out of a SPA. I wanted to have refs, storage, visibility. So these are all plugins I basically sat down and said, I need to write these for myself to get going. And I was like, okay, this will get me started, but it's going to be kind of bloated. It's going to be bigger. The irony is it's actually the smallest framework out there by a significant portion. It's funny because I did all this work to make sure that I could pick and choose and do all this, but the whole thing is 14K, soup to nuts, with every feature, which is kind of exciting because I don't need a marketplace because I've basically made every plugin that every other framework supports I have out of the box. The one thing is, like, people are like, why is it so much smaller? Like, what am I missing here? But the idea is a lot of times people have libraries like HTMX or Alpine or Mutu, like jQuery, and they all have competing ideas of what events are, and they have basically a lot of overlap in how they handle things. So as a user, you're constantly trying to figure out where this lives, where with the data star thing, it lives in one place. So it really makes it a lot easier to use. The signals approach also takes a lot of that reactivity and puts it into the signal layer so that you don't have to worry about it. It's actually very tiny in the amount of code that actually has to be created to make signals work. It's kind of like setting up in Excel a formula that's driven by other cells. You have to put code in very few places to have a lot of reactivity on the page. And also the thing is Datastar plugins are really smart about being aware and actually layering themselves in the right places. Yes?
What do plugins look like?
I can show you to you after. They're usually very tiny because all you're doing is you're saying take the declarative part and turn that into a function. That's literally all it's doing. You're just saying take this declarative stuff I did and run a function on it.
So it's a dictionary of strings to functions.
Basically, yeah. Like that's the general idea. I can get into like how the backend plugin, but even the HTMX complete replacement is 250 lines. Like it is very simple once you have reactivity and declarative nature. So many problems get easier. So that's good news. And also because I'm using TypeScript, for example, in HTMX, there's a million checks for everything to see what's happening because there's so many assumptions happening so many assumptions happening. Whereas I can use TypeScript to check all the invariants at the beginning of the function and then just use things properly. So my code's a lot smaller as well. And the fact that there's one way means it's a lot easier to use. So if you've ever done front-end development, there's a thing called to do MVC. It's basically, there we go. It's basically a very simple to-do app that every single SPA framework can use to basically get an idea of what the vibe of using the framework is. And in this case, I didn't think that was good enough because I'm working on real-time things. I work on things that are millions of updates a minute. And so I wanted something that basically is like, look, I'm going to initialize the page, and then the to-do app can get updates constantly. So I only have, in one get, I should basically have that set up and never have to touch it again. So whenever I get an update, it's getting pushed to me instead of having to constantly pull. So it's going to be faster, more efficient, and hopefully a lot easier to write. And when it comes to updates, it's the same thing. I basically go to the browser, I do a toggle for something, and then somehow in the background, that updates the state, and then that get that's already open is just getting sent down. So this is sometimes called CQRS, or Command Query Responsibility Segregation. You don't need to do this to do Datastar, but I think as you get more ways of interacting with a page or more data streams, this way of thinking of things is so much easier, so that you have one connection that's basically doing those projections, updating the UI, and then your commands are validating, doing all the things they need to do, and then just updating the state. In the case of how I did it, in the example you're about to see, is I love Nats. I work on the team that builds it. So it has a great many features. If you've never heard of Nats before, you really should take a look at it if you're doing any kind of distributed problem. It scales. I'm actually using it embedded. It's just a library, but it can go into giant superclusters, any language. It has key value and object store, and it has persistence and high availability just built in. So when you need to scale something up, it's there for you, whereas you don't have to like have something that works in a simple solution and then it's hard to scale up. It just works out of the box. So in this case, I'm using the KV. I'm using the ID so when you go to the page, you get a cookie. I put an ID in there, and then the value of it's the state of the to-do. One of the nice things about Nats is the KV has a built-in watcher. So I can watch a specific key, and whenever that changes, I basically get an event hook that I can just hook directly into, which is nice because then Datastar just takes that, turns that into HTML, and sends it down the wire. The other thing is it has a TTL, so even if people have people blasting the server, their session only lasts for 15 minutes and then it goes away. It's pretty easy. In fact, yesterday I had a blast of someone on Twitter was talking about it and had 20,000 people hit my server, and it basically I barely saw the blip. So this does work out of the box right now. And this is the basic idea. You hook into it, it catches up, sends an SSE event, and then whenever that changes from anywhere in the system, it automatically sends new events. So yeah, let's go to the Datastar page. I hooked into the internet here, so hopefully we can go there. Sorry. I can just click on that one. That would make more sense. Okay, so this is on my mobile phone. Oh, it's in my pocket. So on my mobile phone, we're actually going to go down to the bottom of the page here. and interact with it. So this is talking to the free tier Fly.dot server, wherever that is. I think it's on the East Coast. And when I go to click on this element here, that's live to the server. There's no JS on this page at all. That's actually going all the way so that all the state is living on that server, and I'm actively interacting with it on the page. Same thing when it comes to, oh, sorry, wrong screen. So when I'm updating the page, this is actually a full, complete round trip that's happening. And even when I go in here and type a new thing on the page, you'll see that this hasn't gone to the server yet, but down here, this input, I'm actually showing the contents of this store so you can see what's going on. And when let me make that a little bit smaller. So if we are updating the page here, you see that the signal is automatically updating, and that'll get sent to the store whenever I do that push or post to get. That'll get sent off, and when I hit enter here, it went off and made a new element on the page. What's really cool, I think, is that because I built this in a distributed way, if I go to here and I basically open up a new, sorry, let me put this down. It's so tiny. Okay, finally. So the interesting thing is, if we go to the original page and we're looking at it, because these are on the same, I'm on the same computer in the same browser, they're actually using the same cookie, which means that when I make a change here, it just went round trip and is updating anywhere, because making collaborative or real-time things now becomes dead easy, because I have as long as I have something that's shared between the state that they know about each other, now I can make real-time things where they can interact with each other, they can collaborate. Making a chat app is very few lines. This entire app, including all of the stuff in Go, is less than 100 lines of code. It's so easy because you're just hooking into these things. You're just instead of trying to create JSON and trying to have an API that talks back and forth, you just take the parts of the page that changed and you re-render them. That's it. No other steps. It really is that easy. And I'm using it actively in production to do some pretty big things. I'm actively making graphs that are updating over 1 million data points every minute for our real-time apps. So we'll go back to here. And of course, I don't have a connection to the internet. But Carson's actually the guy behind HTMX, and that's funny, it's not updating. Even he is saying, hey, you should give Datastar a try. So literally on Twitter, that's why I got blasted yesterday with a bunch of people, because he said, if you're doing real-time applications, really, Datastar is the way to go. So unfortunately, I can't see his tweet because it's pretty funny. But yeah, that's the basic. If you guys have questions, let me know. But whatever backend you're using, give Datastar a try. And if you have questions, please let me know.
So if what you're doing makes it completely REST compliant, including HTOS?
Yeah, HTOS. Yeah, so yeah, there's no right way to say it, but I say it enough that I've come up with my own version.
So it sounds like you're a Rastafarian.
Well, the thing is that I do enough development stuff that if you're going to do hypermedia, do hypermedia. So I love doing RPC stuff. I'm a huge fan of not so much JRP or gRPC, but the buff and connect and that style of, if you're going to do things, it should be binary and vendor and versioned and still be able to be accessible via JSON. But RPC is a different beast. RPC is for how computers talk to computers over an API, whereas hypermedia is about humans, and it's about human interactions and human UIs. So yes, I am a Rastafarian when it comes to hypermedia, which is the whole point. But if you're going to build the other, yeah, you should be building an API, and those are two different problems, right? So that's my answer to that for sure. You had a question?
Yeah, I was just curious if outside of real-time applications, if this is worth like your usual web app sort of thing.
Yeah, so the question was, is it worth it for just regular web apps? 100%. In fact, the irony is that what we found, I have a guy that's using it for a bunch of ML model, like real-time app stuff, but he started using it even for his onboarding part of his page. And the reason why is he would do a post saying, hey, we're updating your credentials or something like that. And that actually became, instead of just being a standard web form, all of a sudden he could say, oh, I want to tell you that I've done this part of the step and this part of the step and this part of the step. So even on a basic form, you get access to those things, but you're paying, the only thing that you're paying extra compared to just a normal HTTP call is you're paying for like one extra header saying this is a text HTTP stream, and you're paying for about 6 or 7 bytes extra data. So my thing is this scales from a standard web form all the way up to real-time hypermedia applications, which is the stuff I work on, and it does everything in between. So I feel like that's actually easier because I have one way to do things, and it scales up to any problem set. So I found that that's way better for the kind of stuff I've seen. So I 100% think that if you want to have, the other thing too is that you're changing the paradigm because you have one place to validate. You have one place to, like, would I make something that's invalid on the page? I don't have to keep like a div element that says, hey, this is an error, and then I have to hide the error, and then I have to style it differently. I just dump the thing on, if it has an error, I append it onto where the form was before. So it makes so many things so much easier that you will see that you want to update parts of the page depending on what's going on with validations and checks and all this stuff anyway. It just makes sense to be able to have access to the entire page and update it dynamically. So, yes, sir.
It seems like going back to the server all the time is going to cause serious performance issues. And serious, I mean, your page really should work offline, though not everyone does.
Yeah, so it depends on what you're trying to do, because I will, the thing is that, again, DataStar does completely offline and completely online, and it handles both situations. In fact, one of the things that is built in, I actually have built in online, you can go to the website and see an example. I actually have a data dash online and data dash offline and a data dash sync. So as soon as you get back online, it automatically sync your store immediately for you. So all these things, because that's when people say, oh, it's like an HTMX clone. It's not. It does everything HTMX does, everything that Alpine does, and a lot of things that neither of them do out of the box. So you can make a completely offline app. I just think that as soon as you start talking about real-time and interactive content, you have to be connected anyway. So how I use it is fully connected, but I built those features for people that are doing offline first stuff, like local first. Because I also have things to tie it directly into local storage. Because again, these are just plugins, data dash local. It's pretty easy to add your story. Basically, you're saying sync it to local every time it updates. So these are pretty simple. Yeah. Yes, sir.
I have a question about the server side because I don't really do a lot of web development these days. The client side part makes a lot of sense to me. I absolutely love the way you presented this. It's fantastic. I'm having a hard time kind of imagining, like, what does the server
look like? Yeah, let me actually show you you want me to show you the to-do app? Because I can show you the good web. Yeah, absolutely. Give me 1 second. I'm not used to holding the mic.
We're a little over time, so try to.
I will go super fast. Let's see. See if I can just share that. Make it bigger. Okay, we'll just close that. So this is so this is the whole to-do app. When you go to the first page, you're saying, hey, I'm going to create a SSE, which basically allows me to send events down. Then I'm going to, in this case, I'm watching for that event bus, like I said before. I just do a watcher, and then I look for that event. The context that's done in the Go case is basically saying the client closed the connection. So if they can't close the connection, then I just exit out. Otherwise, I'm going to watch for events. And in this case, it was marshaled as JSON. And then when I'm done with that, I basically just take the state of that server and just render it to a template. That's it. So that's the Go side. That's literally the projection side. And then when it comes to each of these things, like for example, if I say I'm going to reset the form, all I'm doing is saying, get me the content of the from the key value store. Just get me the current content. I'm going to run a command saying reset, and then I basically save off that and send off a new event. Or in this case, I'm not even sending off a new fragment because that's going to update the key value store. So that's it. That's all the code. And I'm just doing that for each little function. When I go and say cancel, the code looks the same. I'm basically modifying it and saving it off. Same thing with changing the mode for the filtering. There's nothing, you notice the data start part's tiny because all you're doing is saying, I need to update, for the commands, I'm just sending back saying, hey, it's an ACK. Whereas the projections, all I'm doing is rendering the part on the page. And if we actually go to the part on the page real quick, because it's just a template. In this case, I'm using temple. Let's see if I can. Home temple. Yeah, in this case, it's just standard things. Temple is kind of like JSX for backend, for Go, but it's the same basic idea. I'm just working directly with the state. So instead of trying to change it into JSON and then change it back into JSX or something like that, I'm literally just using the state and rendering the fragment on the page. That's it. There's nothing else to it. It really is that simple. So, yeah, I guess we ran out of time. So. Oh, yeah.
That was an awesome talk. Thank you very much. Curious what Black Ops stuff you were doing too. Different talk for another day. Okay, cool. That's awesome. Maybe you can come back and share us what you can share. Awesome. Thank you, everybody, for coming out. I appreciate all of our speakers today. Thank you, Rich. Thank you, Delaney. I appreciate everybody for coming out. Thanks, Ryan, for recording. If you want to get in touch with me, like I said, for the JetBrains license, just grab my card here at the front and reach out. Grab a sticker on your way out. Got some cool stickers there, too. So thanks, everybody, and have a great day.